Hello, everybody. This is Salsa Sommelier, or OK Settle Down, or Clark Newman, and today we're going to be doing a ISS prayer report. That's me right here. So let's get right into it. That's me again. Let me make me small. And so what we're doing today, let's zoom in here. This started with a suggestion, or somebody asked me, have Muslim employees at NASA figured out the direction for Muslim astronauts to pray at the ISS? Our Malaysian astronauts have this problem. This came from a older article here, How to Face Mecca from Space. So I could write a simple FreeFlyer mission plan that would return the angles from the ISS to Mecca and the ISS body frame, so you can know which direction to point yourself while you're inside and relative to the ISS in order to do your prayers. Daily reports with angles generated for each local prayer time can be made. Read that backwards. So coming back here, I said that's what I'm going to do, and that's why we're here right now. So let's go ahead and look into what we need to do this. So the first thing we're going to need is the ISS state. The first thing we're going to need is turn on FreeFlyer. The next thing we're going to need is the ISS state. So the way to get the ISS state, the state meaning the position velocity, I'm going to go to spacetrack.org, which has states in the form of two-line elements for everything that's in space. So I happen to know the, hello, here's FreeFlyer. Oops. We will be working with you in just a second. You can stand to the side, FreeFlyer. All right, so we're going to be looking for, where is it? SatCat ID 25544. That is the space station. That is the ISS. So if you can read this, we are looking at, I'm going to zoom in. We are looking at NORAD satellite category ID 25544. That is ISS. In parentheses here, it says Zarya. That was the first element of the ISS launched by Russia in 1998. So, since 1998, the ISS has been up in space. Here is its orbital parameters: apogee 420 kilometers, perigee 413 kilometers, inclination of 51.64 degrees, and so on. So let's grab the TLE. Boom. We're going to take this guy. This is our two-line element. It's got several fields in it that tell us essentially where a satellite is and which direction it's headed. We will be taking that, putting it into FreeFlyer here. This is a FreeFlyer. If you are a student, you can get FreeFlyer for free. If you are not a student, you can bug me about it, and maybe we can get you a temporary license if you want to play with FreeFlyer. We can work about getting licenses to people as you need them. But one nice thing about FreeFlyer is that it smells a lot like MATLAB, and a lot of the things are not easily, but can be done with Python libraries in MATLAB, not necessarily in FreeFlyer. But part of this is showing the power, how easy it is to do things in FreeFlyer. So we're going to actually build our. Here's our define our ISS. So we're going to load the state from a TLE, and so recall that I just saved that TLE, copied that TLE over here. So now we have our ISS. I'm going to actually capitalize this. Well, no, we're going to leave it lowercase. So let's comment our actual two-line element out. This is our input state, and so we will be grabbing the actual. We can actually feed it a string array with the two-line element directly in it. So we will be doing that. So we're going to just go ahead and pass it to a string array titled TLE. So let's build our TLE right here. And I'm just going to copy our TLE. Oops. as a string array. So here is the actual string array. We load it into the TLE, and now for ISS.elapsed, oops, let me put a parentheses here, for ISS.elapsed days so I'm doing things a little bit out of order here. So we are going to load our two-line element. We want to see what we're looking at, so we're going to create a view window that shows our ISS. We are going to ISS.elapsed time is less than time span 1 time span dot from days 1. Okay, so wrote a lot of stuff down here. Oh, actually that parentheses is not supposed to be there. Oh geez, I'm messing this up. Oh, excuse me. That's what the problem is. I'm using a for statement. I should be using a while statement. How dumb. Oh, pardon me. Okay. Spacecraft.load TLE. Load TLE. Oops. Keep hitting the wrong buttons. Okay. So what we should have here. All right. So that was very quick and dirty. Let's slow this throttle down. Oh, there is no throttle. Let's do this. Let's update and then let's pause 0.1 seconds. And so what we should be seeing now, I will run this again. And now we see our ISS very quickly going around the Earth. We've given it, so you can see it traveling from west to east in its inclined orbit. And so now we have our ISS propagating over the course of a day around the Earth. And that only took us just a few minutes to get there. So the next step is to define our ground station, Mecca. So we need its latitude, longitude. So let's go get those. Here we go. So Mecca is 21 degrees north, 39 degrees east. So just to be clear, the longitude of the ground station east of the prime meridian. So east is positive, going from the prime meridian, which goes through Greenwich, England. This will be positive, not negative. So now we have Mecca. Let's go ahead and throw Mecca into our view. So let me redefine that, do a little bookkeeping. So now we want to see ISS and Mecca. So let's run this again. We're going to save this prayer report. Okay. Now we have right here on the west coast of Saudi Arabia, there's Mecca. So we've defined ISS and we've defined Mecca. Let's go back to our page of things we need to do, which I must have gotten rid of. Okay. So let's stop this. Let's come back in here. So this is the very beginning of it, right? So we've got the next thing we need to do is actually create our prayer report. And so in order to do that, we need to actually define our prayers. There are 5 prayers through the day. I'm not going to pretend that I know anything about it. I want to help, but I'm not going to explain or try to decipher what's going on here. All I need to know is that there are 5. They're at 5 times in the day, at sunrise. Let's see, at dawn, midday, afternoon, sunset, and at night. So let's bring that. So the problem with being in space is that dawn happens every 90 minutes. So if you are beholden to the sun, you will be praying 5 times every 90 minutes. That's not very feasible. So what we would like to do instead is create a prayer report that makes some assumptions on what the astronaut is, how the astronaut would be behaving if they were on the ground. And so they typically, because you have a normal work day on the ISS, everything actually tends to be in the Houston time frame, or rather the Houston time zone. So we're going to assume, moving on, that everything's going to be on the Houston time zone, Central American or Central U.S. American time zone, and that is generally Greenwich Mean Time plus 5 hours, or subtract or add 5 hours to get to Greenwich Mean Time. So for starters, we're going to just use Greenwich Mean Time, and then we'll just shift everything over to the Houston time zone. So we're going to create a array, or a list of times in the day. So we can call those hours. So we're going to call this an array of prayer times. And so the prayer times, we're going to just give in 24-hour notation prayer times at dawn, midday, afternoon, sunset, and night. So for dawn, I'm going to say 0600, 6 a.m. For midday, noon. For afternoon, let's say 3 p.m. or 15 hours. Sunset, let's say the sunset's at 6 o'clock p.m. or 1800. And then at night, looking into this a little bit further to see what they really meant by night, they meant before midnight. So we're going to say 10 p.m. or 22, excuse me. So those are going to be our 4 prayer times. So every day at these times, we want to get the angles. Excuse me, I'm having a time here. Okay. So we're going to step the ISS, update the view, pause for a second. Now we want to determine if we're at a prayer time. If ISS.epoch UTC, So epoch starts from, excuse me, I'm thinking to myself. So epoch or time span epoch in FreeFlyer is in modified Julian date format, which basically means a big number, where integers, whole numbers are days, and within the day is a fraction of a number. So we took these prayer times here, right? So we want to normalize them to a day. So let's get our prayer times in day format, equals prayer times by 24. So what we're going to do here, is we're going to kind of march through our day, and anytime we cross where the below a full day crosses any of these thresholds, we'll ping and say and get our angles to Mecca from the ISS. So if ISS.epic dot one of these guys rounded to truncated. Yeah, you're gonna have to listen. You're gonna have to deal with me trying to figure out exactly what's the best way to do this. So we're gonna have to do this rounded to days. So excuse me. We're gonna do ISS.epic minus ISS.epic.rounded to days. That will give us the fraction underneath the day that we're looking for. So we're going to have to actually go through this for I equals 0 to, first we'll have to define I as an index. So we're going to have to run through our prayer times, and if we cross any of the prayer times, then we will need to go ahead and report a prayer at that time. So we've got our prayer times per day. Let's go ahead and make another array flag prayers completed. And so we're going to say flag prayers completed dimension is the same dimension as prayer times normalized in units of day. So these are all going to be zeros. All right, so for I equals 0 to, actually we'll just say the flags dot fill 0. So this means no prayer has been done. So as we go along our day, we start our day and we start going. We're gonna go through our prayer times, and if we have is greater than hello. Oops. Oh, we're gonna have multiple conditions here. Is greater than prayer times day, the ith element of that, and flag prayers completed. That prayer has, if we've crossed that prayer time and that prayer has not been completed, we need to report ISS dot azimuth to Mecca. Now let's trigger that prayer complete. And let's move on. We've got too many end statements here. Okay, so let's see what's going on here. So we're going through a whole day, and we step the ISS, update our view, pause for a second. We can get rid of this pause. So let's comment that out. So as we go, we're going to ping each prayer. And if we've crossed that prayer time and the prayer has not been completed, report the azimuth angle, flag that prayer as complete, and then move on. So now we're ready to test this. So, okay, first off, we've got some typos and bugs. I'm matching the dimension of the flags to the actual number of, again, we got a dimension here, not just the actual thing. So this is a time span. So we need to set this to .2 days. So this is going to be a fraction of 1 day. Okay, So we're going to debug this. We're going to run this and debug this. So let's run it. All right, so I'm stepping through this guy now. So we're going to step our ISS. Let's update our view. Where does that put us? There's Mecca. Where's our... Oh, we can't see it yet because we haven't done a step yet. So let's see. Let's do a test here. What is this value? Let's look at our inspector. This is just a way of debugging. So 0.26. And what's our first prayer time in terms of fraction of a day? 0.25. So we've already passed it. We start just past the... So now we should skip the rest of these because we have not passed any of those other prayer times. Okay, good. So now let's take another step. Update. Where are we at in the day? So we've already completed that prayer. Now what I want to know is I want to update. We should be watching this number creep up. So our next prayer occurs at midday. So let's go ahead and just move our breakpoint into... Uh-oh, we have a problem. Only one prayer was triggered. Okay. All right, let's run this again. We got a bug here. We got to debug. So we immediately trigger, jump in. Let me zoom this, push this out. Let's look at have our flags been triggered erroneously? All right, so we're gonna... Oh, interesting. I see what the problem is. Why did this... Oh, because rounded to days. What I need to do is truncate. I think what happened here is that by rounding, it jumped ahead at about half a day, and now we start getting negative numbers there. So what I need to do is not round to days, truncate to days. All right, let's try this again. So that way, even if we're past halfway into a day, we should still get the floor of that value, not be rounded to the next day. Okay, so let's try this again. Now we should see 5 reports of azimuth angle. So I'm gonna... There we go. All right, there we have it. So let's do a couple things here. Let's verify that these numbers are correct. So what we see here is the azimuth angle. And so what is azimuth? Azimuth angle is in opposition to elevation. Elevation, what do you think elevation is? Up and down. Azimuth is around. So in low Earth orbit, I don't care so much about elevation unless you're passing directly over Mecca, where you're looking straight down. The ISS is moving over time. Your azimuth angle may change, actually. So one thing we can look into to round this out, I kind of want to go ahead and stop here today, and we can make our next step in the next video. But what I wanted to add here is let's assume a prayer time of 30 minutes. So if we assume a prayer time of 30 minutes, so a 30-minute prayer time. What are our angles at the beginning and end of each of our prayers if we have a 30-minute prayer time? So we report that at each time we report it. This is what we're going to do now. We're going to save the ISS as pre-step. So we save off our ISS step ISS 2. Let's create another time span prayer epoch. So this is the epoch that our prayer start epoch, excuse me. We want to be precise in our language and our code. So we save it, we save ISS, prayer start epic equals ISS.epic. Step ISS2, prayer start epic plus prayer time. So we step the ISS forward 30 minutes from the start of our prayer. Let's report this again. All right. And then we will restore ISS from pre-step. Let's run this. What happens here? Oops. It fails because I have a typo. What was that? Oh, duh. This needs to be a comparative statement. ISS.epic, step the ISS to or until ISS.epic, its state in time state, is equal to the start epic plus 30 minutes. Let's check this again. Let's run this again. All right, so these are actually a little backward. Okay, we're going to have to actually change this up a little bit more so this is more legible. So we're going to call this, we're going to need a variable prayer as start, prayer as end. ISS.azimuth of Mecca. So we're going to get our start and stop. And then we're going to report this to the console. Report prayer, and this is prayer I.format. This is a integer. Azimuth, starting azimuth equals prayer start as dot format. We'll give that a single point decimal floating point number, and ending azimuth equals prayer as end dot format %.1f. All right, now I'm going to comment these older reports out. Aha, here we go. Prayer 0 starting azimuth is 28.7 and ending azimuth is 153.4. So there's actually quite a bit of change. 30 minutes in orbit is a third of the orbit if we're talking about a 90-minute period, which is what the ISS has got. So we actually have quite a bit of shifting in our azimuth angle from start to stop of prayer. Now, if we take our prayer and our prayer is only 15 minutes long, let's see what happens. So we run this again. And we see these azimuth angles don't change as much depending on where you are. Let's actually put in a breakpoint every time we have a prayer. So let's run this and see, let's actually visualize where our prayers occur in space. So our first prayer, where are we? I can't tell because I'm going to just step once. Hold on. Okay, so our first prayer, where were we for our first prayer? Oh, we were right over I guess, Western Africa. So yeah, we're coming right at our azimuth changes quite a bit as we're coming right over Mecca. So let's go to our next prayer. Prayer 1, we do several orbits, and then prayer 1, we are starting to go near the South Pole scraping by the edge of Antarctica. We are below or just over the southern tip of New Zealand. And so where's our next prayer? Where's our next prayer? Oh, similarly, we're back in the south side again, in the southern Indian Ocean. All right, so this is where I'm going to stop today. Let's run this to the end. All right, so we've got a very basic prayer report. We got our 5 prayers. They start at 0600, noon, 1300, 1600, and 2200 or 10 p.m. We define a prayer time, 30 or 15 minutes. I'm not sure what it's supposed to be. Please let me know. And then we report the beginning and ending azimuth. We may want to report the middle azimuth. So at this point, I would like to ask everyone, what's the best way forward from here? Do we really expect somebody to rotate at a constant, and it wouldn't even be a constant rate over time? As you can see, and maybe this is something that we can look into, is what is our prayer rotation rate over time for any given prayer. And that's going to have to be for next time. I'm going to stop it here. This is the very basic. We got from 0 to our prayer report, and this is an extremely basic prayer report. I think there are lots of things we can do to make this better. For one, we can put this on an actual letterhead and email it out. We can automate that. We can create automated notifications. We can actually format this into a document. We can include more data, a header with the date, our daily orbit numbers. We can include this into a wider schedule of activities that happen on the ISS. I think what we want to focus on for our next trip is to look into these specific prayers. What is our prayer rotation rate? Should we do that, or is it good enough to assume a mean azimuth and just point in that direction for the duration of your prayer? I'll have to take some guidance on that, but thank you for for sticking around this long. This has been using FreeFlyer to very quickly determine which direction you need to point in order to do your 5 daily Muslim prayers. I remember one more thing we need to do. I mentioned this is kind of in the body, or this is in the Earth fixed frame. So this is all relative to, I guess, the latitude and longitude of the ISS and Mecca. But the ISS attitude itself changes over time. It normally maintains a local vertical, local horizontal attitude, which kind of means it looks like an airplane flying through space. It actually rotates with the Earth. Here we go. It actually rotates with the Earth. It doesn't stay in one. So because it kind of flies and follows the curvature of the Earth, this is a pretty good first cut for telling someone which direction to point at the times. We ultimately want to put this into the body frame of the ISS so that you're working with the ISS local coordinate system. But that's for next time. All right. Thank you so much. Bye.